Bluff Point in Groton, Connecticut has a mostly rocky shoreline, which is a result of the deposition by the late Wisconsin Glacier over 20,000 years ago. The largest rocks that are found here are called glacial erratics. The physical composition of rocky shores is relatively complex in the way that rocks and boulders are different sizes and oddly shaped from weathering, leaving various crevices, rock pools, and gullies. Rocky shorelines are known for the constant push and pull of tides. Depending on where you are in the tidal cycle, rocks will either be covered with water, partially covered, or left uncovered, providing different conditions at different points in the cycle. This allows for an increased variety of organisms and plants to survive and thrive in these habitats. Overall, compared to other types of shorelines, it can be argued that rocky shorelines could physically be fairly resilient to modest sea level rises. This is most prominently because of the hard, rocky composition of these areas. It is unlikely that they will erode away due to sea level rises, and they should in fact somewhat maintain their profile. The organisms and plant life that find their homes in these rocky shoreline areas, however, are not as resilient as the rocky substrates are.
An important part to the coast of Connecticut is where our rivers meet the Long Island Sound. Our rivers are responsible for many geologic and environmental processes, including sediment transport and the transport of fresh water to the Sound. In addition to their geologic role, rivers have also been an important aspect to human use over the years, including milling and transportation purposes. Currently, there is a large amount of infrastructure in close proximity to the rivers of Connecticut, including many highways and our capital city. Because of our reliance and geographic closeness to rivers, it is important to understand how they work and how they may react to sea level rise. So first, a little on how rivers work. As rivers reach the end of its course, also known as the mouth, the width and depth increase while the slope and mean velocity decrease. This change in shape and behavior allows for more deposition to occur. When a river meets a standing body of water, the sediment it is transporting starts being deposited, and this creates a delta. The significance of the river's shape is in the gentle gradient of the slope as it approaches the Sound. As we know, areas of low slope will be more affected by sea level rise than coastal areas with steeper slopes. This puts a red flag near any large rivers discharging into the Sound, such as the Housatonic, the Quinnipiac, the Connecticut River, and the Thames, as these are areas where increased surface area will be affected. Based off the model produced by the USGS Coastal Marine and Geology Program, sea level rise may affect up to 6 miles upstream in the Connecticut River. Sea level rise will cause the mouth of the river to migrate upstream, flooding the current delta and lowlands. Effects of this will definitely be felt in towns such as Old Saybrook, Old Lyme, and Groton, as they may start to feel a little wetter. Overall, it is in our best interest to monitor rivers, their deltas, and surrounding areas, as they will be one of the most affected when a rise in sea level occurs. Not only will they be significantly affected, but these lands are also highly populated and used frequently for recreational use, as well as important areas for biological activity for the Sound.
As was seen in the presentation, salt marshes are coastal wetlands that are flooded and drained with salt water brought in with the tides. They are marshy due to the substrate being composed of up to several feet of thick mud and peat. Peat is waterlogged, root-filled, and very spongy. Oxygen levels in peat can be very low due to the amount of decaying plant matter and constant submersion. Salinity is also typically much higher in a salt marsh than in the ocean. Salt marshes occur across the globe and thrive in protected areas, such as Long Island Sound. They offer an invaluable habitat for nearly 75% of the world's fisheries species, ranging from shrimp and crabs to finfish. Along with providing such an important habitat, salt marshes protect the shoreline from erosion and help filter runoff and prevent flooding. New England salt marshes were established roughly 3,000 years ago after post-glacial sea rise decreased. In recent centuries, sea levels have begun to rise again, with dramatic increases in the past few decades. In Connecticut, salt marshes exist in a narrow zone along the coast, making them very susceptible to this sea rise. This is detrimental to the health of our salt marshes. In areas where the marshes cannot keep pace with rising sea level, there is a loss of habitat for marine life. This also results in more flooding and less filtration of groundwater as the plants and intricate root systems die off. In areas where the salt marshes can keep up, they are extending into residential and commercial areas where they encounter seawalls and developments which restricts the salt marsh's ability to grow, leading it to drown in the rising sea level. Studies from the Connecticut College show that in any event, salt marsh efficiency is lowered as sea levels rise.